AI Alliance, we were formed actually by IBM and Meta, and then we brought in a bunch of other companies with the purpose of working to move AI forward through open and open source and all things open. And so, in fact, there's quite a few AI Alliance members here today. You just heard from one of them, Philip over at Neo4j. You heard from Snowflake earlier. There's quite a few member companies here, and it's really nice to be here with all of you. With me, you heard Joe's introduction. He's been influential in so many different ways, even in the AI Alliance. So leading up some of our early working groups around trust and safety and models, quite a few areas where he's been influential. So it's a real pleasure to be with you, Thanks. Joe, in person, finally, after all this time. So yeah, great. Just a few opening words. I like to be fluid around questions and topics, and I just think, glancing out at the audience here, listening to the topics earlier today, we have a wide range of skills and interests, so we're going to try to keep this dynamic. You just came from the PyTorch conference.
That's right.
OK, so we're going to start off on a little bit on a technical topic here. All right.
Yep, sure.
So why don't you for those who don't know, just a quick introduction to PyTorch and why it's so popular.
Yeah, so I guess before I even answer that, I guess a little bit about me. I guess I've been in the AI space for over a decade now, I guess almost 12, 13 years, and kind of worked at every single layer of the stack, from I would say the lowest levels to kind of how models are authored, to hardware. I have a double E background actually, and then all the way up to building large language models. So I led product for anyone heard of Llama, the Llama models? So I led the open source effort and us building models and releasing models for Llama. And PyTorch is kind of how these things get created. I actually penned a blog post earlier this year called The Open Language of AI. And I think PyTorch is kind of that. It's a connective tissue, and it's how a lot of this is built. ChatGPT, Anthropic and Claude, everything we do at Meta, lots of other companies, it's all built on this thing called PyTorch. And people build, it's not just one thing, it's an ecosystem, and it's a lot of components, and it's how you author and how you deploy and how you train at scale and do all these things, how you deploy to devices and all that good stuff. So all these different layers kind of fit together. And I think we're in this position now in the space where every single of those layers is being disrupted. So all those things that I've been working on for all these years are now completely being rethought and being disrupted, which is kind of fun because it keeps me employed. It keeps me energized and engaged. But everything from how the little kernels, for example, transformer architecture is made up of a bunch of layers, right? And these layers are made up of matrix multiplications of different shapes and sizes. That layer is being disrupted completely. LLMs are literally generating those kernels for training and inference and accelerating them. And we can write really great kernels, but there's literally less than probably 100 people in the world that can write these ninja kernels that are really efficient, that are great. LLMs and these agents are actually allowing us to do that and be able to scale it to many more people. So even that layer is being disrupted. But how we think about reinforcement learning, how we think about deployment, everything, every layer at this point is actually being disrupted.
So it's like the body of AI or generative AI is going through evolution in right before our eyes.
That's right.
Yeah.
I mean, how we orchestrate we're actually thinking about how do you actually train across data centers, because we can't co-locate enough compute or GPUs or power in one place. So can you actually run a lot more asynchronously? So historically, we've done everything kind of synchronously, and you've done things like all reduce and all communication. And now we're actually thinking about how do we actually maybe do some things in one data center and maybe scale up part of the workload in another data center, and those things are done asynchronously. And then how do we then incorporate reinforcement learning, which is if anybody read the DeepSeek paper. Actually, anyone read that paper earlier? Okay. It was a great Christmas present when you have your in-laws in town and you want something to do, right?
Stocking stuffers, yeah.
Stocking stuffer, right? It was a great paper, great read. But it really kind of thrust reinforcement learning into the forefront of things when it had been kind of the background for many years. And now the whole kind of space is waking up to RL being really important. So we released an RL library that allows you to scale up reinforcement learning and even do it asynchronously and build models and post-train. So my goal is always to democratize, but yeah.
Yeah, definitely. And by the way, does that library have a name?
It does. It's called Torch Forge.
Torch Forge.
So I know we really struggle with naming, But yeah, our library is called Torch Forge, and it's kind of built on this thing called Monarch, which is the layer that allows you to kind of scale across the data center or across data centers and so on. So
yeah, naming things.
It's
one of
really
the most
hard.
difficult things.
It's
yeah.
harder than building it.
Yeah. So, okay. And by the way, so in the very early days of PyTorch, when it was still more of a research project or an engineering project inside of Facebook, Joe was one of the folks who said, no, we got to double down on this. You want to tell just a little bit about that? Because that's, to me, as a developer community person, like how did you spot that and realize that that was going to be so important?
It was actually pretty interesting. So PyTorch, if you didn't know, was evolved from a project called LuaTorch, which has anybody used the Lua language?
Yeah.
Very few people. I guarantee there's like one person in this room has heard of Lua. So it's not a very popular language. Python is obviously more popular. People write a lot of Python. And so the project in probably 2016 or so evolved to start using Python as the language. And it started really as a research project, with the premise of how do you basically make researchers productive? How do you allow them to essentially express any idea effortlessly in Python? Because Python is extremely easy to write. Anyone can kind of pick it up. It's very easy. And it's kind of become the language of AI development. And so, how do you just make these researchers express their ideas? How do you allow them to iterate and explore the space? And so it really started out this research project, and it was all about training, right? Because you wanted to be able to train models and see how good they are, and then, okay, that's not good, so I want to retrain and build a different model and try a different architecture. And so it allowed you kind of to ablate the search space, really, really quickly. But then we saw basically that these models were starting to creep into production, which is really cool, right? Because then you get all these the great ideas and computer vision, natural language processing. These were cool audio, right, speech. And these things were ASR, models or automatic speech recognition. These things were starting to slip into production, but we were on kind of two platforms. We had this kind of research platform, and then we had what we were building in production, and they were two different things that didn't speak to each other. So we saw this as a problem statement for Facebook at the time, now Meta, but we saw it actually as kind of a global challenge that we saw. Everyone was kind of dealing with the same challenges, and at the same time, the space was exploding. I mean, maybe not to the level it is now, but it was exploding, right? And we saw this way to kind of tap into the innovation that was happening and kind of create a bridge, or what we like to call lingua franca, to the rest of the community, and kind of curate and be able to cultivate and harness the kind of innovation. And so that was one of the reasons why we were so open source centric. Is there were all of these, say, NLP and computer vision experts, and they were training models and building on our platform and on PyTorch, and that actually allowed us to accelerate internally. So we kind of harnessed the power of an open community and kind of made Facebook better as a platform. And so I think it was early 2018, we kind of came together, and after a lot of discussion, we're now's the time. We have to do this. We see this deluge of research and all this good stuff that's happening out of research, and our goal is to get it into production as quickly as humanly possible. And if you have too many roadblocks and too many friction points, it takes time. And at that point, I think it was taking us upwards of over a year, or a year to get a model from research into production. It was crazy. And by that time, you moved on to the next couple of different architectures, and the AI space moved fast at the time. So it just, on its face, it just made sense to kind of create one uniform, one platform, research to production, lower the friction, and that became our mantra, is how do we accelerate all this good stuff. And so for example, when the computer vision, when people were building convolutional neural nets, these CNNs, new architectures were literally coming out weekly. People were building these new new things. They were built on PyTorch, and we're okay, that looks good. We're going to retrain that and deploy that, and that helped us with our our integrity. So a lot of our when there was hateful memes or sexual content or these things, we actually improve our classifiers literally week by week because of the innovation that was happening outside. So it just made sense for us.
And so, just from a practical perspective, it had been used in research, but the production platform was very different. So you couldn't, that whole PyTorch kind of, you made it so that it would do what was happening in research, but for the production platform?
That's right. They literally spoke a different language.
Yeah.
In this case, the language we call, it's an IR, right? It's an intermediate representation. It literally was very different. You had to convert it. You had loss in that conversion. there's different things you optimize for in research versus production. Production, you want performance, you want latency, low latency, you want stability, reliability, all of these things. In research, you don't care, right? You just want to explore the space, find the best model, find the best architecture, solve a problem, solve some tasks, and then you kind of like, you have a bit of a breakthrough maybe, and then you can be able to incorporate that into a product in some way. So you kind of have different things you're optimizing for in those different things. So.
And so you can see from a kind of economic perspective, there's a lot of companies who are now benefiting from PyTorch, which is an open source project, and they were simply solving their own problem. One of the things I do love about the big tech companies in Silicon Valley is that a lot of them, they want to create something that gets used by the public. So one of the benefits for Facebook and other companies like Facebook or Meta is that it's attractive to engineers to participate in a project and get their baby released and then used by the public, right?
Yep.
And so, I know there's so many projects that you have released over the years. And I come from kind of like the database world, so like Cassandra, and which, by the way, IBM just acquired DataStax. So like, think how that path went, right? So, so much of it out there. Now, at the PyTorch conference, you announced quite a few projects. Do you want to share with us some of those projects?
Yeah. So I think 6 projects we released. I kind of mentioned the stack earlier. So we released a project called Helion, which allows you to basically in say like 20, 30 lines of code, write a roofline or a state-of-the-art kernel. So if you're kind of like exploring the training space and new architectures, if you're a researcher, like it's a very low barrier to thinking about like new model architectures. So that was we're co-developing that with like Google and NVIDIA and AMD and a number of others. We released a project called TorchComms, not too sexy, but it's a communication kernel library that allows you to scale essentially infinitely in the data center. So we believe like we've tested like 100K or more GPUs, which is pretty crazy, right? You're talking about like compute like never before being used at scale. And basically that allows you to basically distribute compute in your data center and communicate across nodes. We released a project called Monarch, as I mentioned. That was, if anyone's heard of like the project called Pathways at Google, it's kind of a similar vein where you can basically do asynchronous distribution of workloads across data centers or across within a data center, kind of cluster scale. But the beauty of that project is you can actually be writing local code like you normally would. So like who's used the Jupyter Notebook? Like hopefully like everyone, right? So it's great. Like it feels like you're, by the way, bless you. Someone really has to sneeze over there. But like Jupyter Notebook is like the easiest way to get started in like development, right? You shift enter, you can like play with code cells and so on. We made a project that basically allows you to kind of write code and develop in an environment like that, but it could be backed up with as many as 100,000, 200,000, 300,000, a million GPUs, and you wouldn't even know it. And so like you can kind of get to the point where you're doing almost like interactive research, and you feel like you're kind of writing on your like local Mac. So it's a really impressive project.
Yeah, anybody here have 100 million GPUs or whatever it is?
I do. Then we released a project on top of that called Forge, as we talked about, Torch Forge, which allows you to do reinforcement learning across all of that infrastructure. And then lastly, we released a project with Hugging Face called OpenEnv. And so one of the things that's really, as I mentioned with DeepSeek earlier, that's been kind of like brought to the forefront this year especially is reinforcement learning. And when you do reinforcement learning, you're thinking about basically, kind of states and actions and environments. So, think about like the classic reinforcement learning problem is like a game. And you think about a game where you give the agent some controls. And the simplest game, they used to use like Pong and like Breakout and these things, right? And, you kind of move the controller left, right, move the controller right, up, down, press buttons and so on. And you get basically some action space. And then once that, it will basically take those actions and you tell it what the reward is, the score goes up. It will take basically, it'll randomly take those actions until it starts to figure out how to make that reward go up, in this case, a score. And so in this case, we've actually become much more sophisticated in that our environments actually could be a web browser. They could be some type of shopping environment where you want to have an agent go shop for you, and you tell it what to go buy for you, and it will have a reward, and it will go and come back and hopefully bringing the right things into your shopping cart. It could be a coding type of environment where you want it to generate code for a certain problem you're building, you do vibe coding and so on. And that's how these models are learning now in post-training. You'll have a bunch of these environments, and these are essentially agentic environments that they'll go off and they'll play around, basically. Think of it as a sandbox with some action space. The model will then go play around if given a reward, and it will come back and it will learn. It will basically accumulate rewards by learning in that action space or in that environment. And so we created a standard and a hub for how you actually create these environments. And so there's like Pokemon environments. Believe me, by the way, the Pokemon environment is actually incredibly complex. You wouldn't believe it. And there's way more people that like Pokemon than I thought after the last couple weeks. So yeah, I think 6 projects we released, and it's been a pretty awesome reception so far. So.
Okay, let's double click on that OpenEnv, because we were talking earlier. We were talking about how reinforcement learning, having everyone do it yourself may not make sense because there's just so much that goes into that. But if there's a proliferation of maybe OpenEnvs or environments that you can use instead, that's based on somebody else's reinforcement learning. Am I saying that right?
Yeah, reinforcement learning is really, really tricky. It really is a research problem still today, although we're gradually pushing it more towards the mainstream, and we're trying to provide some like standards and libraries that are easy for developers. So, I think that there is an open question right now of if everyone is going to be doing RL or not. So, for example, like let's take an example of a company like an enterprise, and like say we'll take Meta for example. Meta has a lot of internal programming languages and internal data and internal systems that aren't public, right? They're just not public, right? They're closed behind our firewalls and within our data centers. And you want your model to be able to generalize over all that information, right? Maybe we want to have the model, we have this thing called MetaMate internally, and that's what we use essentially as our like kind of ChatGPT. And so when at the end of the year, we do our performance, and I want to summarize like my performance or whatever, I call MetaMate, and it goes and searches all my docs and what I've done, and summarizes my like, what I've done for the year and my like accomplishments and feedback on me and all that good stuff, and it's great.
Can you slip it a 20?
You can definitely you can reward hack it for sure. Maybe, I don't know, but it needs to be able to kind of you need to have all that data in distribution. And so what we do as a company is we create environments over internal data and internal systems, and we will run reinforcement learning over those environments and incorporate that data into the model and into the agentic system. And so you can imagine like all of even your personal information and your personal systems or whatever you want, you eventually may want to, we all may eventually have these things running on our devices or whatever, such that we're RLing over them, and the model itself is learning to personalize to us. And I think that's like, it's like kind of an important part, I think, of where we're going. And it's also actually good from a privacy perspective, because you can actually then incorporate all that information like locally, say it does it on your device, and you can personalize it, and you can keep the weights like on device and never go to the cloud. So there is a kind of an interesting like dynamic of privacy as well with environments. But yeah, there is an open question of whether it's the foundation models themselves, like us and OpenAI and Anthropic, are kind of like the companies, and the foundation models are doing all the RL, or it becomes a democratized thing. I think it's potentially somewhere in between, but it's still, we're still very early on in this journey, so we'll see where it goes.
So I do feel like I have one more question to get to the bottom of this.
Sure.
So the OpenEnvs, if there's a proliferation of those, then you can use those to run your own reinforcement learning?
That's right.
Right, okay.
So I think if you look at, so it's not enough, I think, to provide like an RL framework that gives you the algorithms and the library. You actually have to have the environments to be able to do RL. And I think that's one of the things we're trying to democratize and give people equal access to is, much like on Hugging Face, I think there's, millions of models, right, literally, that you can go and you can download. There's like a fine-tuned derivative of Llama that speaks Japanese or, is fine-tuned on different healthcare data, and there's all these things out there that people have created. Much like that, there's this community forming around environments, and you can imagine like different coding environments or coding languages. You could basically think of it as a skill set that you want your model to learn, and just like this skill thing, this like skill set, and it's a box. It's this box that your model basically can interact inside of, and it will come back with skills. And so if you want your model to learn Julia, for example, really cool language, right? In the HPC world, give it a Julia environment. It can RL over it. It's going to start to learn Julia. And so people have started creating these things, these kind of like skill sets, what we call environments, and it becomes this kind of virtuous cycle of people building these things, using them, sharing them, and all of a sudden this thing starts to democratize, and a lot of people can do it, which is pretty cool.
Okay, so one more. So if you have if you're building your own model,
yes,
you could collect a variety of OpenEnvs.
Yep.
And then tell it to go learn from each one of them, and then that model will basically have learned, like it took different courses almost.
Basically, yeah.
And then that model now has, a degree.
I think so. I mean, there's going to be, yeah. I mean, I think that's a good way to actually put it. I think there's definitely going to be a dichotomy in terms of like, we as Meta, for example, we build environments. We have our own environments. We source environments from startups and vendors. There is an element of secret sauce, right? In terms of like the golden environments that you build on.
Sure.
And then I think that there's this world of generalization that is going to happen with these frontier models, where the world is building these things, much like data, right? And we talked about Common Crawl before we got up here. There's a sea of data, and there's of course data we have as a company, and data that IBM has as a company, and so on. And environments are very similar in that regard. And so, I mean, our goal I think is really to bring this in the hands of all developers and actually allow people to take their models and actually build on their own applications, much like they used to do or still do today with like SFT, right? When they're doing supervised fine tuning over their custom data. In this case, they're just learning their own skills through environments. So.
Yeah, fascinating. We're going to run out of time here, and I have a bunch of questions, but I'm just going to stick it to one. We briefly talked about developers building applications using AI. Okay, we talked about it before this panel, and I thought it was interesting. One of the things you said was that product managers are actually vibe coding.
Yeah.
So tell us a little bit about that.
Yeah, this is
at Meta.
At Meta, yeah. So PMs are actually vibe coding products, and we're showing them to like Zuck and leadership, and it's allowing us to like iterate and explore the space really fast. And so we're to the point now where like the coding, Cloud Code and like our own internal systems are getting really, really good, and we can literally vibe code products in a matter of like hours or days, and explore the space and change colors and change ideas and change, the UI is like completely like, you can manipulate it in real time, and so if you have ideas, like there's not much holding you back from like putting a prototype together really fast. And I'm seeing this in the startup space as well, because I help co-create a lot of companies, and there used to be hey, we have a team and we have a pitch deck, we're going to go pitch and see if someone will give us money. They're actually like vibe coding prototypes before they even go to VCs now, with like a handful of people. And I mean, there's a solo founder that I know that she just literally prototyped something in a matter of like 1 to 2 weeks, and she's like raising money, and same with another one. So I think like we're getting to the point where we can, like, the barriers are really low right now.
Yeah.
It's really up to you and your creativity and what you think is like, like cool ideas of cool things to build and the problems you're trying to solve. But literally PMs at this point are vibe coding, using Claude and other things and coming up with prototypes, and it's like really crazy. The velocity is incredible.
Yeah, I've seen some amazing things too, although I still have not seen somebody vibe code into production and then continue to vibe code. Have you seen anybody do that?
I mean, so I was having this discussion earlier this week. I was another thing, the AI list or whatever it was, and I was having like this back and forth with someone around, it was actually Paige Bailey at Google. Her and I were actually back and forth around this. Like, if you can vibe code something, and when the cost is so low to develop something, you can literally throw it away and do it over again, right?
Right.
So what is, what happens when literally like the cost of code goes to basically like almost zero, right? And the agent itself, like there's systems like, if you're familiar with like Pulumi, there's this guy Joe Duffy out of Microsoft who started this company like 8 years ago, and he built this agent called Neo, and it will go and it will essentially manage your code in production. It'll build infra as code. Like if you write, what is it, Terraform, like it'll go and do all that for you. People hate Terraform, no offense to Terraform people. But like their agent will go in and literally write it all for you. And then when dependencies break or like there's breaking changes or whatever in your code base, it will go in and it will fix those, or at least like come back with like a suggested set of things to go do, and you like, yep, go do that. So you're still in charge, right? And so you can imagine like vibe coding something and building an application, deploying it, throwing it away and doing it over again when you want to change it or whatever. But if you want to keep it in production, the agent itself will actually go and manage all those dependencies and manage it in production for you. It's pretty weird dynamic when you think about it. It's kind of where it's going right now.
It is. I just need somebody to be able to vibe manage my database.
Yeah.
Because that seems actually kind of hard.
I think there's companies I know of doing that.
Doing that?
Yeah,
okay. All right. Maybe that's our next topic, because that is hard on my end. Well, wonderful. Okay, we're in the red here. So is there anything you want to leave, like final parting note?
I mean, I think the barriers are so low right now. Like, I think I tend to like operate very deep in the stack as a deep tech kind of person, but like, I think like right now is the time to innovate. I think this is the barriers are so very low. You can basically do a lot of what people are doing, say 10 years ago with prompting, and so I think my only advice to you is like explore, like don't be afraid. This is what I tell like PMs at Meta and other places where I mentor other PMs. Like, don't be afraid to like get your hands dirty, and honestly, they don't need to get that dirty these days. Like so my daughter plays Roblox, she loves it, and I taught her how to use Cloud Code as well. And you can basically hook it up to like hook Cloud Code up to like the Roblox SDK, and it will go generate worlds. And so she's like playing Roblox, and then she's vibe coding basically new environments to play in Roblox and at the same time. And it's like, whoa, like my daughter's 11, right? And I mean, I couldn't even imagine. I mean, I've been programming since I was probably about her age, and like maybe I was 12, and like I couldn't even imagine doing what she's doing now. So get your hands dirty, play. It's like it's all out there, and a lot of it's open too, right?
Yeah.
So there's no excuse.
Yeah, it is. All right. Well, thank you so much for sharing all this. It's been wonderful.
Cool.
Thank you, everyone.